All right, guys, this video is going to help you do derivatives of things that aren't necessarily polynomials, but we're calling them polynomial-like. In other words, I'm going to rewrite each of these functions that you're looking at in example 1 so that it looks like a polynomial, so that I can then use the rules that we learned yesterday. So if you take a look at example A, I'm going to rewrite this as 7 times x to the negative 4. All right, because the way it originally looked, right, over here, right, the way it was given to you, it's not a polynomial. But the way that I wrote it, now it is. So I can now do the derivative, which means I'm going to take this exponent, I'm going to multiply it by the number out in front. I'm going to subtract 1 from that exponent. Keep in mind, this is a negative number. You are subtracting 1. All right, and then all I have to do after that is clean that up by putting the exponent in the denominator with a positive exponent. Okay, so let's try B. Okay, now this right now, again, let me highlight the one I'm doing. I'm doing this. And the first thing I want to do to this function is I want to rewrite it because it's not a polynomial. But I can rewrite it as x to the third over 2x plus 4 over 2x. Now, both of those fractions simplify. So let me simplify both of them, making the first one x squared over 2 and making the second one 2 over x. All right, and again, I'm going to kind of rewrite that just one more time so that it looks a little bit easier to do the derivative of. I'm going to make it 1/2 x squared plus 2x to the negative 1. Now, again, I want you to notice I have not done the derivative yet. All three of those things that I wrote was just a way to get this to look like a polynomial. Now, when I do the derivative, 2 times 1/2 is 1. Subtract 1 from that exponent gives me a 1. Here, when I multiply the negative 1 times the 2, I get negative 2. And when I subtract 1 from negative 1, I get negative 2. Now, let me clean that up again. So I have x minus 2 over x squared. And I don't want this to be two separate fractions. I would prefer that it be combined, so I need a common denominator of x squared. So I'm going to have x to the third minus 2 all over x squared. All right. All right, let's go down here and try problem C. So let me highlight the one I'm doing. I'm doing this one in green. Okay, so I'm going to rewrite the problem so that it looks more like a polynomial. And now I can go ahead and take the derivative. I'm going to use this notation. 5 times 1/2 is 5/2. Subtracting 1 from that exponent gives me negative 1/2. And now I just need to clean this up. So I'm going to have 5 over 2. And when I move this into the denominator, I will have this. You also have the option, if you'd like, to write it as the square root of x in the denominator, if that's what you prefer. All right, so let's move this over and try this last problem. Okay, so I'm doing this one in purple. Okay, so step number 1 is I'm going to write this so that it looks like a polynomial. Okay, so I'm going to write that as x to the 1/3 plus 4x to the negative 1 minus 5. And then underneath, I'm going to go ahead and use my derivative notation. And I'm going to take the derivative. So negative 5/3 x. I'm going to subtract 1 from that exponent, so that's negative 2/3. Then the next one becomes negative 4x to the negative 2. And then the derivative of this constant is just 0, so I'm done there. Okay, now let me clean up each of these terms. So I'm going to have negative 5 over 3x to the positive 2/3 minus 4 over x squared. Okay, so now I don't want this answer this way. I would prefer that this be one fraction with a common denominator. Okay, so my common denominator is going to be 3x squared, which means that this fraction over here is going to have to be multiplied by 3 on the top and the bottom. And this fraction over here is going to need to be multiplied by x to the 4/3. And I will be more than happy to explain how I got that. If you're not quite seeing it, ask me about it on Friday. Okay, so my numerator is now negative 5x to the 4/3 minus 12, and now over the common denominator. Okay, so now the lower half of this page is talking about something called higher order derivatives, which means instead of just doing the first derivative, we can do the second derivative or the third derivative or the any number derivative. Okay, and I want you to see some, again, new notation. My favorite thing ever, notation, notation, notation. So you know how we've been using this for the first notation? Well now, or first derivative, we can now say, well, that's the second derivative, and that's the third derivative. But most of the time, we don't use this notation. It's not really accepted as well as these other notations that you're seeing. All right, it's called Leibniz notation, and I would prefer it if you are doing anything more than like the second or the third derivative. Okay, so this example, number 2, is asking you to find the first 5 derivatives. So again, the first was very, very visible. Here is the derivative. First derivative, 4x to the 3rd minus 15x squared plus 8x minus 8. Okay, that's the first. Now for the second derivative, and again, watch the notation. Watch where the squares go. Okay, second derivative with respect to x. But again, second derivative. It's just the derivative of the derivative. Right? Just look up above, pretend that was the problem that you originally had, and do the derivative of it. Okay, so then the third derivative is going to be 24x minus 30. All right, I'm running out of room, so I'm going to come over here to do the fourth derivative, which is going to be 24. And then the fifth derivative. Derivative of the constant is just 0. All right, if you have any questions, hold on to them. I will be back on Friday and answer whatever I possibly can. And good luck.